Hi, Professor and TA. The topic of our report is to integrate the Group2 and clip models and apply both of which to the image caption generation. And we hope we can benefit the social media users. Our team members include me, Guangze, Jiawei, and Dunhan. We will discuss our motivation, how we decide our experiment, and the model we use, and our results. As for why we decided to work on this experiment for our report, it is because we hope to generate cutting-edge models to generate captions that are highly related to images for social media users, so they don't have to come up with the content, the text by themselves. For the first scenario of our experiment, we use only Blip2 model and evaluate the generated captions using BLEU and ROUGE scores based on the reference caption. We then use the Blip2 to generate 5 captions, and you further apply the clip model to select one with the highest similarity to the image as our second scenario. And following this, we further fine-tune the Blip2 model and repeat the first and second steps as our third scenario and the fourth scenario. Here is the structure of our experiment for scenario 2 and 4. We use the Blip2 model to generate captions, and both the generated captions and the images again become the input for the clip model. Then we get the sentence of highest similarity with the image.
Blip2 and clip that we use for creating captions for images. First up, Blip2, it starts with the image encoder that takes an image and translates it into data that the model can work with. Then comes to the self-attention component. It looks over this data to pick out what parts of the image are key. The cross-attention step is next, where the model starts to connect text to the image. After this, the feedforward network shapes this information into a caption that's accurate and readable. The final steps in Blip2 are image text matching and text generation, which work together to ensure that the caption is not just correct, but also relevant to the image. Moving on to clip, it operates with 2 encoders, one for understanding text and the other for images. Clip's job is to assess the captions created by Blip2 to make sure they are the right fit for the picture. In simple terms, Blip2 writes the caption, and Clip gives them a quality check. To fine-tune an LLM model such as Blip2, we utilize 3 distinct datasets, employing the PEP package from Hugging Face to leverage LoRa for resource-efficient tuning of large language models. During the fine-tuning process, we tested 2 configuration settings. The first featured a relatively larger learning rate with fewer epochs, while the second utilized a much smaller learning rate across a great number of epochs. Results showed that the large learning rate did not lead to convergence. Instead, the loss increased as more epochs progressed. Conversely, the second approach, with a smaller learning rate and more epochs, led to a stable decrease in loss, culminating in satisfactory evaluation metrics. Consequently, we adopt the second configuration for our fine-tuning process. To assess the effectiveness, we input a test image into the fine-tuned Blip2 model, comparing the original and fine-tuned captions. Moreover, we also use the aforementioned evaluation matrix, which is Blue and Roche, to appraise the fine-tuned Blip2 model's performance. Diving into the project results, we observe distinct improvement across our evaluation matrix, particularly when we fine-tune Blip2 using parameter-efficient fine-tuning. The enhancement in Blue and Roche scores are evident, especially when comparing the longer captions in the 220K dataset, which is table 1, with the shorter one, which is table 2. This fine-tuning allows the model to more accurately capture the character of the image descriptions. Interestingly, while Clip's role in caption selection does not automatically evaluate scores, it does not negatively impact the fine-tuned model's performance. In fact, with fine-tuning,
The integration of CLIP even offers slight score increase in some cases, suggesting that the fine-tuning process enhanced the quality of captions generated by Blip2, making them more robust against clip selection. Turning our attention to Table 3, with the Flickr 30K dataset, we see a less pronounced but still positive effect of fine-tuning. It seems the Blip2 model was already performed well with Flickr 30 caption, suggesting the model and this dataset are well matched from the start. The improvement, although modest, affirms the value of tailoring the model to the specifics of the dataset. To summarize, fine-tuning emerges as a tool for increasing the model's capabilities.